So I'm really pleased we've got Larry Kavanagh here today from AISI, American Iron and Steel Institute. He's the president of the Steel Marketing Development Institute within AISI. He's responsible for developing strategies to advance the competitive position of steel in multiple markets according to SMDI's mission and goals established by the board. All of that aside, you want the person that's pushing science and technology for the steel industry in this country. It's Larry that's been doing that. He's pursues that with relentlessly with our office, let's just put it that way. And we've had some great projects we've worked together over the years on this, and really pushing forward on some of this HPC for manufacturing. I hope Larry can share some of his observations and the experiences we've had.
Thank you, Mark. Appreciate the really kind introduction. Hope I can live up to it. It's an interesting perspective to talk about high performance computing and what's possible. And I think my approach for everybody today is to kind of give you a sense, to stretch your mind and imagine what might be possible based on what's already been done. When I started in the steel industry, some 30 years ago, we had no performance computing. Okay, it was at the very beginning, and I started in the steel industry actually in process automation. So the parallels between my own career and our partnership with the Department of Energy and its various manifestations goes back 30 years as well. We did our first project in 1987. So I can give a little bit of, kind of how steel rode the technology wave, the ever exponentially increasing computing power wave, and tell you what we did with that. And that's kind of a peek at bringing the next generation of computing power to bear on steel or American manufacturing, and really think about what's possible, because it's really exciting. So going back to the no performance computing days, we weren't able to apply process automation like in real time directly online because our processes move faster than computers could react. If in the early 80s, if we were able to measure some process variable once every 2 or 3 seconds, we were doing really, really well. And now, of course, we're measuring many thousands of process variables, many thousands of times per second. In just a little basic kind of steel industry math, in our rolling mills towards the finishing end, a sheet of steel will be traveling somewhere between 40 and 60 miles an hour. So the idea that, how much a lot of steel passes by in 2 or 3 seconds if you can only measure at that frequency, so you really don't know what's going on in the material, what's going on quality-wise. So the steel industry was an early adopter of any automation advances. If you have a steel plant in your area, I urge you to contact them or contact me. We can arrange a tour. It's really fascinating deployment of technology and a fascinating story. But anyway, where we're at over the last couple of decades in what exploding computing power can do for you. We now understand what happens. Steel starts as raw materials, then it gets melted, then it gets re-solidified. We could only guess before about what happens during that solidification process, what happens, where the quality and property is formed. And similarly, when steels are heated and cooled and rolled, we can now understand, we now know, we can model, we can see it on a computer, how at the molecular level the microstructure is formed, the properties are developed. So what does that allow us to do? Well, if you can fully understand the properties of materials and how those properties are formed from first principles, i.e. at the molecular level, you can invent new materials. You can have tremendous improvements in the control of your process, which goes to yield and competitiveness and quality and less waste. All of those things have occurred as we've gone from the days of no computing power, no high performance to current computing performance, which is really good. And we're starting to suck out of universities and laboratories and high-tech companies that the catalyst for that next generation in leaping. So as I wrap up, let me just tell you a couple of the things that have happened over those 2.5 decades when we went from no performance to current performance computing. The steels that we make today are 5 to 6 times stronger than those that were made just a few years ago. They're new materials. And what's that mean? Well, to use the automobile example that's been given several times already, vehicles are safer. You know, the safety requirements for vehicles today are as tough as they've ever been in the history of the automotive industry. And these new materials allow us to safely protect occupants. At the same time, these seals are so much stronger that you need less of them to create your vehicle. So therefore, you get significant advances in mass reduction without sacrificing safety or performance, which helps automakers achieve the fuel economy regulations that are increasing in stringency going forward. That's just a couple of examples. There's similar ones in buildings and construction and bridges, et cetera, et cetera, et cetera. But what it's meant as an industry, just from the process control point of view and the performance point of view, since 1990, our industry has reduced its energy intensity, meaning energy use per ton of steel produced, by 31%. That's significant. Similarly, CO2 reduction per ton of steel produced is at 36% lower than 1990. So I can tell you that, you know, the past, I think, proves the future. The steel industry, and by extension, American manufacturing, but the steel industry and enhanced computing performance and power are inextricably linked, and they have one thing in common. Neither steel nor computing power has reached the limit of its performance yet. And by thinking about how you pursue reaching that limit, that's when you start to think about the advances in manufacturing competitiveness that can be brought to bear across all of our industries. And so that's my message for today is imagine what that's like, and let's enable it, because I can imagine a lot. Thank you, Mark.
Great. Thank you, Larry. I think one of the powers of the work that you've done is bringing together within the steel industries, the steel companies working together all the way down to all the providers of that innovation, and really getting that dialogue and prioritization of what do we need to work together on really worked on. And to highlight that, one of the places I know I've visited a few times is Purdue Northwest, I guess they're called Purdue Calumet. It used to be.
Purdue Cal, yeah.
Where you take the high-performance computing work, and it's fascinating, and wind up putting into immersive visualization. So you put on the goggles, and you can actually walk around basically inside of like the steel itself. It feels like where you're in there in terms of but understanding what's actually happening. That also points to the importance what we end up having of how do you bring to bear by bringing these universities in. It actually gets your next generation of workforce.